consult as their IT consultant and IT trainer. This is my colleague.
Yeah, my name is Lavrinovich. I'm also working together with Alexey in the same company as a consultant and trainer. Yeah. So today we're going to talk about challenges in day 2 operations with the Cloud Director. So basically, you know that in the Cloud Director, not too much automation from the management perspective. Yeah, and we usually, when we are working with the Cloud Director and you need to create a lot of tenants or new tenant, new organization, we need to set up it manually. And basically it's a first challenge which is displayed on the screen. It's a time-consuming operation. So it takes time. You need to assign a task to the engineer or operator to create an organization, then virtual data center, and so on. So all the manual iterations bring to inconsistent operations, inconsistent configuration because of probability of the human errors. And because of the human errors, we are increasing the situation, risk of this situation when we can get a inconsistent configuration, or maybe we will get some errors in the configuration which lead to some vulnerability or security issues in the system. And when it comes to the massive organization, deployment, or creation, we are meeting scalability issues. And scalability issues basically coming when we have to create many organizations with the same configuration. Yeah. So, and of course, without proper automation, we cannot roll back or go with the proper version control. And of course, since it's a manual configuration, when we have a new customer, we need to onboard this customer, we need to assign the task to the engineer, and as the outcome, we will get in a slower customer onboarding. Yeah, maybe our customers will not be happy about this.
Yeah. Here's an example of the legacy automation approach that we were using as the person who were working in the organization, one of the biggest service providers in the CIS region. We were using the Excel spreadsheet to storing the information where the times were with the version of the Cloud Director 8.1. I guess some of you know that before the time where the HTML approach was the Flash client and all these kind of times. Yeah, we were using the Excel spreadsheet as the source of the truth for managing the organization. And you can see in this example, here is an organization VDC with what kind of CPU quantity, what kind of storage profiles is used, what kind of networks was used for the creation. And this Excel sheet contains all the necessary data about organizations. It contains also the different sites, for example, the SPB site, NSK site, IP addresses there, and other things. And this was the source of the truth, and there was the PowerShell script that was using and utilizing the Power CLI and the automation using the PowerShell API calls within the Cloud Director for the creation based on the data. Here is the small example of the utilizing the storage policies and also the speeds of the provider VDC. It is choosing what kind of PVDC and what speeds needs to be done there. But this is in the past, and now we need to understand that the customers always want to have the robust and the scalable solution, because you are just not supposed to solve those challenges and streamline the provisioning process.
Yeah, basically after such challenges, we decided to use DevOps approach or GitOps approach together with infrastructure as a code. And in this slide you can see that we have two main theoretical bases. So we following the approach infrastructure as a code. So we are using Terraform for the automation of the Cloud Director organization creation. And we are using GitOps in order to store the code which we're going to run to deploy the new organization and provide the necessary configuration inside the tenant. And since Terraform, it's our infrastructure as a code approach, yeah, it's a tool, it's basically a language, declarative language, where you can define the desired state of the system or environment. It allows you to build your infrastructure with the versioning control. And on this slide, you can see the example. In the Terraform, we define resources. Each resource represents the object in the infrastructure. In our case, this is part of the resource, or it's a resource which defines the organization inside our Cloud Director. So with the Terraform, we can gain consistency, repeatability, and enhanced reliability. So we can reuse the same part of the code. In a Terraform, we can create a module, and then we can call this module as many times as we need for each and every customer. So this is how we can, this is what we are using in our approach.
And as Alexander said, the reproducibility is the greatest thing, that you are understanding that this model is working fine and you can do that thousands of the times. And every organization will create it without any kind of errors on the same versions of the software. Here is the typical customer workflow, but we adapted it in the terms of the CI/CD pipelines. You know that when you are onboarding the customer, you have your clean Cloud Director infrastructure. It having the provider VDC. It has the integration with the NS6 and the, for example, N6 ILB. And now you are onboarding your customers. First of all, as the service portal, it can be any kind of system, like, for example, support system ServiceNow, or any kind of platform as a service, like Backstage. You are creating a subscription request. This is kind of, I want to onboard a new organization, and this organization needs to have some resources. We are running the CI/CD pipeline and starting the tenant creation. Tenant organization is baked by the new organization in the Cloud Director. Then we are starting the assignment of the user. It can be local users, it can be SAML users, or any kind of integration using, for example, LDAP as the backend. For the storing the images, we created a separate catalog for this particular tenant and the customer. We started the creation of the VDC. VDC contains what kind of provider VDC we are using, what the CPUs we are using, what the memory limits, storage limits. Then, after the new VDC is created, we're creating the Edge Gateway. Edge Gateway is baked by the NS6, because I guess most of you already migrated from the NS6V to NS6T, and this is the current supported functionality. Yeah, and when we created the NS6, we need to make routing networks, organization VDC networks. It's done by the new NS6 segment, and if it's needed, we can also adapt and store some firewall configuration. For example, you want to have some predefined rules for allowing those kind of access of the organization VDC networks directly to the internet. Or you want to create the source NAT translation using the IP addresses, external IP addresses that you are pointing to that particular customer. And if you have the AVI load balancer integration, you can also do the configuration of enabling the service engines and the configuration of that parameters.
Yeah, basically it's a basic idea or basic example. It could be more complicated, of course. Yeah, and this is what we can describe with the Terraform. Yeah, and with the Terraform language, we can use infrastructure as a code approach, and this is what we said. We put our code in a GitLab. In our case, we're using GitLab as a Git repository. And in the GitLab, we can execute CI/CD pipeline. Basically, it executes the code which is in the repository. And as a result, we get a already prepared organization in the Cloud Director. Yeah, so when it comes to GitLab, the main feature which is really interesting is a pipeline. Because usually when our manager or engineer or operator enters information about new organization, yeah, we have a new request for the pipeline execution, or whenever you push a new code in the repository. And the pipeline, basically it's a specific, in our case it's a container, and the container we take the code from the GitLab repository and we execute a lot of steps. So you have CI pipeline and you have a CD pipeline. CI, continuous integration pipeline, can prepare your code. It can go through the many checks like security checks or code syntaxis check and so on. And if CI pipeline was successful, then we can continue with the CD pipeline. Basically how it looks in the GitLab user interface. So you can see here that pipelines contains three stages. I'm not sure if it's visible. It's not visible here. So the first stage is build stage, where we can it's an example not related to our use case. It's just an example where we can build the code. Then on the second stage, we go through these different jobs to check our code, unused variables, security checks. We can see if we can run Terraform plan, for example, and see if the result is quite fine, and we can continue with the deploy. So after the second stage, we can go to the third stage, deploy, and finally apply the changes in our infrastructure. And now we're going to show you how we implemented this in our environment.
Let's try to move this window right here.
We need to stop the presentation.
Yeah.
Let's stop the presentation.
check. Yep. All right. Just give me 1 second. And let's go this window right here. Yeah. Here we can find the Terraform model. As I said, the reproducibility is a great feature. You have the one model that contains all the information related to the creation of the code. We have some requirements and resources that we are creating. Let's look into the model itself. We have the main Terraform model that is containing all the resources that we are currently creating. We are starting with the VCD organization, VCD users, organization VDCs with the needed settings, and VDC group and VCD catalog. After that, we also mentioned that we can do the separate models. For example, you can create the separate model for the firewall, for the networking, for the ILB, and separating the files. In our case, we moved the network for the creation of the T1 gateway, and we are also utilizing the private IP spaces for using the organization VDC networks. We also activating in our lab and in our onboarding for the customers the DHCP service on that particular routed networks, and creation of the NSX ILB with mutual virtual services 4 and reserved services. For the IP sets, we can also use the NSXT IP sets as the resource and pointing the needed objects for the creation of the firewall rules. In our case, we're creating 2 rules that is allowing the traffic between the OC VDC networks to anywhere and vice versa from legacy networks to the OC VDCs. We can show you, because it's a model, you can just simply use the model option with the source that will point to your version of the model.
Yeah, so GitLab can organize its own repositories for different stuff like Terraform modules. So you can publish the module, and in the deployment code, you can reuse this module with the specific versions.
Yeah, about the deployments itself, because it is a matter to store the information for every organization in every project. It's as for me, the good approach, where you are creating the separate deployment, which contains the information only for that particular organization. If you want to make the changes, for example, the customer want to have more CPU or more memory, you're just simply making the changes in the deployment. After making the changes, the CI/CD pipeline will understand, okay, we have the Terraform state, we are comparing with the state that we currently have, and if we have something to do, he just making only the changes in that particular parameters for the CPU, for the memory. If everything is fine, you will just have an organization with the updated settings. Here is an example of the deployment that we will use for our demo. In our Explore org Terraform, we just pointing to the model VCD, which is created, and we just adding only the information that is needed for us. Information about the memory guaranteed, CPU speed, what's the network pool will be used, what's the name of the provider VDC, and the storage policies in our example. We have 3 different storage policies, and we are creating the organization using them. But before we will go about the CI/CD pipeline, we mentioned that there is a separate file called .gitlab CI YAML, which our developers created separate pipeline for those kind of things that contains different stages like audit, build, test, deploy, publish, and cleanup. Every of these stage is responsible for that particular audit. For example, is, as Alexander said, checking the code for any kind of variables that is not used, the non-optimization thing, security stuff. Build will do the Terraform plan for understanding that every resource is in place, everything will work fine, and only after it will be succeeded, we starting the deployment. And we are storing currently our VCD password, URL, and user as the variables inside the project. You can do storing your sensitive data in the, for example, HashiCorp Vault and Connect, and storing those kind of things. But for making life easier for us, we just storing that in that variables. And I want to make some changes, for example, in this file, and we will show you what will be under the hood.
Yeah. Once we make a change in the code, the GitLab configured to trigger pipeline. So whenever you commit your version of the code, or whenever you make a merge request in a GitLab, we trigger the pipeline execution. And in this case, so Alexey has some changes in the code, and then you can see that GitLab automatically triggers the pipeline containing 4 stages. In our case, the first stage is audit stage, where we can check the formatting of the Terraform code. We can see the validation procedure and the additional TF-lint check for the unused variables and so on. If you go inside the job, you can see the output of the job. As I mentioned, the job, it's GitLab creates a container where it executes the job. So you can see the output of the job. And can you go back to the pipeline? So you can see that all 3 jobs from the first stage were successful. Now we can continue with the build stage. In the build stage, we have only 1 job. It's a plan. We're checking if the Terraform plan command can be successful.
Yeah, as you can see here, we are pointing to some version of the VCD provider. We are using VCD version starting from 3.11, and currently the latest available is 3.14 because our version of Cloud Director is 10.6. As you can see, when we are planning our resources, he will show you that these resources will be created. In our example, Edge Gateway, Organization, VCD Catalog, IP space IP allocations, routed networks, VDC networks, and also the firewall rules, and so on. Yeah. After you can see the job was succeeded, we can go back and move to our deploy state. It takes a couple of the moments to refresh the state, but yeah, when it's starting, you will see that. Let's move this window right here and go to the Cloud Director. Yeah. If we will go to the monitor tasks, you can see that the new organization starts to be created. This is 11.18, yeah. Using the user Terraform. After he created the organization, he created local user, organization VDC, and now...
Can you refresh the pipeline?
Yes.
Because sometimes it freezes in the web interface.
Let's do the refresh. While it's refreshing the state, we can go directly to the organization called Explore org. And we will see that the tenant is successfully created. And you can see there is a steps that is done here. Currently, it's working on the organization VDC group, which our organization VDC data center will be the part of. Yep, here we go. This is the example of the Oak VDC. Let's see that the properties that we set up in our configuration file is the same. If we will go to our organization right here, you can see that allocation, in our case, is the pay-as-you-go, because our file, if we will go to our deployment, in our deployment of the Explore org, we are using the allocation VApp. That means the pay-as-you-go. We are setting 20% of the memory guaranteed, 10% of the CPU guaranteed with the CPU speed 3.1. Our network pool is our NSX 01W01 pool. Yeah, everything is fine. From the perspective of the storage policies, in the VM, let me go back a second. As the storage policies, we've got our 3 different storage policies, one with the size 10 GB, one with the size 20 GB, and 121 GB.
Necessary limits.
Yep. From the perspective of the Edge Gateway, we can go back and continue showing us the current pipeline. We've got a new Edge Gateway which is created, and it's currently doing the configuration of networks and connecting them, because we have 2 routed networks and they are baked by the IP allocation. We can go to the IP spaces, and we have our private address IP spaces which have 2 separate prefixes, and those prefixes are currently used because they are connected to the 2 networks. One network is already up and ready, We also, in our configuration, enable the DHCP. And as you can see, we successfully added the DHCP pool with the some IP addresses in there. And let's go to the firewall rules. No, let's go to the load balancer settings, because it's currently working on the load balancer. As you can see, currently it's inactive, but after, I guess, 10 or 20 seconds, it will change the state from inactive to enabled. Yep, it's active with premium features activated. And in the settings of our service engine groups, we successfully added our virtual services and mapped to the needed segment of the load balancer. In the firewall rules, you will currently see 3 rules. By default, it will create the one rule, default rule, that will deny all the traffic. And as I mentioned, we creating something like the static groups and the IP sets. Yeah, here is our static group, which is created, and we can manage the members. And we automatically added our organization VDC network directly to that object. And we, after that, can use that in our firewall rules.
Yeah, by the way, job has
finished.
Succeeded.
Yep. Yeah, and in our case, we created the separate IP set with the 10.0.0/8. Yep. As Alexander said, our job successfully finished, and yeah, I guess that's the thing that is proving that it's currently working. In the future, we are planning to add the whole support for the service providers for the object that they are currently using. The great feature that VCD providers non-stop and they add the features, for example, for the container server extensions. You can also onboard your customer with the Kubernetes cluster that will be baked by the Cloud Director. If you want to use the additional features for the platform as a service, you can also utilize the databases services, which is also can be baked with the container service extension for PostgreSQL, for the MongoDB, or any kind of additional services.
It's quite flexible. You can implement almost everything.
And one of our goal later on is to implement those kind of things in the project called Backstage. This is kind of will be the platform as a service and the self-service portal where every of the user can just simply log in and ask for the new organization, and after the whole Terraform code via CI/CD pipeline will be finished, we'll have the working organization with the needed resources.
Yeah, so basic idea to make a simple web interface where administrator can log in and trigger the pipeline, entering necessary variables to the web interface.
Yep.
Not dealing with the GitLab or coding itself, just to make life easier. So this is what we're going to present or extend this idea and show today at the hackathon. Yeah. So please, you can join us if you're interested.
If you have a time, it will be really grateful to see you in the evening.
Okay, so let's stay connected, and you can contact us through our company site. So you can scan a QR code, you can find our details and contacts at our company site. And if you have any questions, we have, I think we have a few minutes for the questions.
Yep. Thank you so much.
Thank you.